welkom bij de Nederlandse Kubernetes podcast over Kubernetes voor iedereen. Het is een ander soort intro dan jullie gewend zijn. We moeten het alleen doen zonder Ronald vandaag. Dus nog steeds op QCon. We gaan over storage praten. Dat is één van mijn favoriete onderdelen. So, I want to introduce you to Travis Nielsen. Travis, can you tell us a bit about yourself?
Yeah, great. Glad to be with you here today and talking about Rook and Ceph and everything storage for Kubernetes. That's what I do for fun. Well, more for work than for fun, but it is something I've been doing for the last number of years. I was one of the original creators of the Rook project.
Okay, cool.
So about 9 years ago, 2016, we started the Rook project. And it's been a good journey. So I'm sure we'll talk a lot about it today.
And how did you get started in the IT?
Going back in my journey of all of this, I started at Microsoft doing setup for Windows Server. Then I went and followed someone to do a startup doing storage, cloud storage for a few years. And then that kind of evolved into, Kubernetes is the future of distributed platforms. And this is I guess that gets me all the way up to 2015 or so when we started looking at Kubernetes and what do we do for storage in Kubernetes. And we really looked at Ceph and created Rook out of all of this to say, well, we need storage for Kubernetes. So that's the really short answer to to the journey to get into Rook.
Okay, and can you explain to our listeners what Ceph is and what is Rook?
Mm-hmm. Okay. So what Ceph is, Ceph provides storage, and Ceph is a data platform that's been around and people using it in production for over 10 or 12 years now, where you need to be able to store your data in a reliable way that's not just on your local disk. You need to do it in a way that's compatible with distributed applications. You need your data to be available from your distributed applications, and you also need it to be durable. So if I have loss of some part of my system, I need the data to still be available in my system. So Ceph is all about providing that storage, and it will provide that storage in three different storage approaches. You've got block storage for your just raw storage where you need just a raw block device. You've got the shared file system where you have multiple clients that need to share and work with the same data. And then you've got your object storage where, think of Amazon S3, where you just want to put large amounts of data into some data lake. And so Ceph provides interfaces for all three types of those storage with a single platform. And so Ceph was designed from the ground up to be a software-defined storage system, and provides all of those in one system. There isn't really another system out there that I've found, at least, that does that in a way that's really built from the ground up to be software-defined for all three types of those storage. And the other great thing about Ceph is it's open source, so it has a great community around it. Donated to the Linux Foundation a number of years ago, so it's all part of this great open source community, and that's one of the big reasons we took a bet on it these years ago when we started Rook. And I think that was the next part of the question.
Mm-hmm.
So, what is Rook?
What is Rook?
So when we were looking at the distributed platform and we started looking at Kubernetes, Kubernetes was still quite young back in 2016, and with 2016 we started thinking, okay, well what can we do for cloud native storage? That was our original goal. Like cloud native was the cool term of the day. And Ceph being software defined, we thought, well, okay, how can we bring Ceph to the cloud native world? Because Ceph was designed before cloud native was even a thing.
Mm-hmm.
And so we started to build kind of our own system based on etcd, but we realized, wait, Kubernetes is going to do all of this. Let's take a bet on Kubernetes. And then the term or the concept of an operator came out in right around the time we were releasing Rook for the first time. With there's a Prometheus operator and the etcd operator were the first two operators for Kubernetes that were announced. That was at KubeCon 2016 in Seattle. KubeCon was a much smaller event back then, only about 1,000 people attending.
Yeah, it's a lot bigger now.
Yes, slightly. I think they announced almost 13,000 people for this.
Yeah,
KubeCon.
it's the biggest of till now.
Yeah.
And in the past, Rook did also other storage systems.
Auto storage, or for automobiles, or what type of auto storage?
All other storage.
All the storage, and
Like they did. As we saw, not only Ceph but also the other one, Gluster.
Gluster. Yes. Okay. Yeah, and early on, Ceph was acquired by Red Hat, and also Red Hat acquired Gluster. There was a similar time frame there.
Yeah,
and it turns out at some point, I mean, there was a discussion. Well, which one are we going to take a bet on? And Ceph won that war, essentially. So,
but Ceph is fairly complex because you've got OSDs and you've got pools and you've got lots of things.
Yes, lots of moving parts, and it is a complex system. And where Rook came into play was we said, well, we want to bring Ceph to Kubernetes and marry them together. But Ceph is really complex. Let's see if we can make it as simple as possible. So that was the goal of Rook. Let's see how we can simplify Ceph so it's more usable, more by all of these people who are now going to be using Kubernetes. So that's been the goal from the start of the Rook project, is making Ceph more usable for Kubernetes. Ceph is still as complex as it ever was.
Yeah.
But hopefully we've made it simpler for getting started with Ceph, to say, oh, just create me a Rook cluster. Rook will start Ceph. Rook will manage a lot of the complexities for me. Of course, we don't hide the complexities. If you need to get into the details of Ceph, you still have all those knobs and configurations available for Ceph, but we simplify a lot of the things to help you manage Ceph, make it more manageable.
Okay. I was on a journey for good storage for the last year, and my conclusion was ending at Ceph, but the read-write many option. I see a lot of vendors, and really a lot of vendors use NFS, and you use CephFS.
Yeah.
And is that different or the same? What are the drawbacks of CephFS
compared to NFS? Yeah, we do still support both. So CephFS being the native Ceph shared file system client, and to work with Ceph, where Ceph ultimately provides this platform built on something called Rados. So it's I'm going to forget what Rados even stands for, but it's an acronym for something in the Ceph world. So CephFS provides that layer on top of that base Ceph Rados layer, so that you can have a file system, POSIX compliant file system, and shared and safe to share with multiple clients. So similar to NFS, and you can run an NFS daemon on top of CephFS as well. But maybe I'll go to the scenario. So where would you use CephFS versus NFS? Is usually an interesting question. So at CephFS, if you're running within the Kubernetes cluster, you're running Ceph with Rook, you just want a shared file system. CephFS provides everything you need to within the cluster. I haven't seen much need for using NFS, unless perhaps you have some legacy application that requires NFS. And it's like, well, just use CephFS directly for your applications. We provide there's a CSI driver that makes all of it just work naturally with the Kubernetes storage classes. So you just request you've got your PVC where you request the storage, and you get your CephFS PV that you can then use for multiple application pods. So where NFS usually comes into play is, well, if your Kubernetes cluster is more like an appliance, or I think of it as an appliance where I need something outside the cluster now to access it, because the legacy applications usually don't understand Kubernetes. They haven't been re-architected to run as pods and all of the distributed architecture.
Mm-hmm.
And so if we run the NFS daemon, then it will expose this NFS endpoint to those applications that need that NFS connectivity.
But you don't need NFS. And if the client also outside the Kubernetes cluster can use CephFS, there's no need for that.
Correct. Then there's no need.
Is there, because NFS is old, really old, and has a number of problems. If you do a failover, you have to reconnect your NFS connections. Do you have that same problem with CephFS?
CephFS. So if the CephFS is highly available, and you have with Ceph you have the MDS, that's the metadata server daemon, which you usually are running two instances of it. One's the active and one's standby. So if there is a problem and there has to be a failover between those Ceph metadata servers, Ceph takes care of that internally, and it does the failover. There may be some hiccups during that failover of time of seconds, or hopefully, I don't know all the details. I don't recall how much time to expect, but it is expected to fail over automatically, and the clients will be unaware really of that. Besides maybe some hiccups in the I/O.
Okay, and the CephFS. Now, better scenario. If you run a database on Kubernetes, what is the best way to connect that to Ceph?
Okay, so a database on Ceph. So with Rook and running Ceph in the same cluster, usually a database wants the highest possible performance profile. So usually you'd use the Ceph RBD, which is the block option, and that would allow you to connect directly. But you're not going to be sharing the PV typically. In that case, it's just the database has its storage, and so you use Ceph RBD for that.
Okay, and that's the fastest option in Ceph.
Correct.
And does it support also synced writes?
Synced writes.
And some databases want have an sync ready when they're writing, and that gives some latency.
Yeah. Well, so Ceph is a fully consistent system, meaning every time you write to it, Ceph will not act the write as complete until it is fully committed in the system.
Always.
So, yes, every write for every type of block, file, or object storage, it's always consistent. So as opposed to eventually consistent, which will, it may take there may be some delay there between actually being committed, where if you try and read too soon, it may not look like it's there.
Yeah.
But so Ceph is not that way. As soon as you commit the write and you do a read immediately after, it will always be there, fully committed.
But so if you have a lot of how do you call it, copies of the replicas, it's going to be slower.
Correct. Yeah, because Ceph does replicate the data usually 3 times is the default, 3 replicas. And before it's committed, Ceph will need to commit at least 2 of those writes. So if you write to one OSD, and then it will essentially fan out to the other 2 OSDs behind the scenes, at least the second OSD must commit that before it will act the write. And Ceph is fully aware of, if it's not on the third one yet, maybe the third OSD is down currently.
Okay, so if I have 5 OSDs, it will commit it to 2.
Right, it'll attempt to commit to all 3 initially,
yeah, of course.
But it will act the write after the first 2 are committed.
Okay, so and it doesn't matter if how many replicas I have.
You can configure it to as many as you want. Of course, it costs you more space.
Yeah, of course. But it's
Yeah.
not an speed issue anymore then.
Yeah, there's some performance cost there. Ceph does create the replicas in parallel as well. So I don't know the numbers of how it degrades because people don't usually configure more than 3, but it is possible.
Yeah, I've got a lot of questions, sir. If you come out of a scenario where you have a SAN, so I've got a Pure Store or a Dell or doesn't matter, and I want to run Ceph. What is then the best option to do that?
So, well, Ceph runs on commodity hardware. Are you saying you've got this hardware you want to repurpose for Ceph, or just what does it take to convert or move over to a Ceph environment?
I've got some customers, and they've got high-end hardware, and they want to to move over to Ceph. Do I have to do something special to do that, or can I just give Ceph some lunch?
Yeah, if you give Ceph a raw disk, we'll have lunch. It will go ahead and eat it up. And so when Rook configures the Ceph cluster, Rook will go look for what raw devices are available on each of the nodes, and Rook has this mode where it will automatically discover and say, oh, do you want to just discover all disks and deploy OSDs on all available raw disks that don't appear to have any data on them?
Mm-hmm.
And if so, then Rook will find a raw disk and use it. If there's any file system on it, then it will skip it in that case.
Because Ceph needs raw disks with no file systems.
Correct. Yeah, just a raw disk, no file system. Just give me a raw block device, and Ceph will work with that.
And if I enlarge that disk in the nodes, so I've got now 20 gigs, and I want and enlarge into 30 gigs, and does Ceph see that?
Yeah, Ceph will see that and expand the size of the OSD. It does require an OSD restart to do that resize, but yeah, Ceph does look for that.
Okay, and I have to enlarge then all 3 of my replicas.
There's a decoupling or a separation between what the size of the OSDs and how much space they have available and what replicas are on that OSD.
Mm-hmm.
Because if I've replicated my data to 3 OSDs, if I increase the size of the OSD, that means I can take on more data, but the existing data that's already there is not affected.
Okay. Mm-hmm. I was reading about a crush map. Do you know what it is?
Yes.
Can you tell me what it is?
Yes. So the crush map, it's a very important part of the Ceph architecture that tells Ceph how to distribute the data, the replicas across the cluster. So the crush map essentially defines I think it is the topology of the cluster. Because if you have OSDs, usually you want to define and design the topology so it can handle outages at different levels. So if I have I might have several disks per node. So I've had several. So one OSD is per disk. So I have several OSDs per node. And then I might have several nodes per rack and several racks per zone. You can have these hierarchies. And then the crush map will allow that when I write data into the cluster, Ceph will look at that crush map and it'll say, oh, you want 3 replicas spread across unique zones. So now it will find an OSD in zone A, write the data there, and zone B and zone C. That way your data is distributed evenly across your zones or hosts or whatever failure domain you pick.
Okay.
So that allows the crush map effectively defines how you can survive outages at different levels.
And I have to define that myself?
simplifies all of that for you, so you don't have to worry about the details.
Okay.
All you do is basically tell Rook at what level do you want the data distributed, at the host level or the zone level or some other level. And so Rook will set up the nodes, and all you have to do is basically tell Rook which topology, and you have to label your nodes so Rook knows which rack or which zone they belong to.
Mm-hmm.
If you're running in the cloud, of course, they already have the zone labels on the nodes, so that's easy if you're running in the cloud. If it's your own bare metal deployment, then you would, if you want something besides the host level failure domain, you'd have to define your own racks or zones with labels. But it's as simple as labeling your nodes with those failure domain labels.
Okay, that's awesome. That's awesome. If you, I was thinking about, I've got some customers. They have small clusters. What is the recommended size for Ceph? For how many nodes is recommended?
For any production level cluster, the minimum would be 3 nodes, so that you can have the 3 replicas of the data across those 3 nodes. And if any, because in that minimal configuration, if any single node goes down, the cluster is still fully online, and it works perfectly fine as long as the 2 nodes are still running.
And the optimal size?
Optimal size with Ceph, bigger is always better. Ceph loves loves to scale, or it's really good at scaling, I should say. So if you have more nodes and more OSDs, Ceph will take advantage of that distributed nature. And where Ceph really shines is with that distributed nature, if you have a lot of client applications writing, the distributed connections will really be able to perform well overall in the aggregate. Some people honestly will, may say, well, the Ceph performance isn't very good because my application, if I write directly to the disk, it can do this well, but I see this much drop if I run it with Ceph. Well, that's because it's a single client, and we have to hit the network, and we have to create 3 replicas, and there's a clear performance cost compared to writing to your local disk. But then if you want all the benefits of this software-defined storage, there's that cost. But if you have all these applications that are running independently, overall it will be good. It seemed to have good perf working across the distributed cluster.
Okay. So Ceph scales very good. I was in normal storage. You got a RAID 5 setup. Do you know what RAID 5 is?
Right, RAID 5 would let you survive. Was it 1 or 2 disks loss?
One. And
yeah, RAID 6 is
and
2.
RAID 5 does a parity.
Parity disk.
Yeah, parity disk. And Ceph does no parity. So you've got always 3 times the storage.
I guess we haven't talked about this yet. So there is an option for using something like that, which is called erasure coding. So with erasure coding, Ceph will break up the files into smaller chunks and be able to use parity chunks to replicate it with less overhead of the storage. So let me give an example. So let's say you want to have, because by default with 3 replicas, you have 3x overhead. That's
really a lot.
Right. And there is a way to decrease that by using erasure coding. So let's say I only want to have 50% overhead, or basically 1.5 times the size of the original data. You can do this with erasure coding, where I say I'm going to break it into 4 data chunks plus 2 coding chunks, and K plus M, as the terms are called. So if you break into that, you get the 2 are the parity chunks, and that's the overhead that you get. But the original data is the 4 chunks. That's, say I have a file that's split into 4 parts. The parity is computed, and then those parity chunks are distributed across the OSDs, and that's how. So if you have a 4 plus 2 configuration, which is common, only 50% overhead, it can still survive 2 outages or 2 losses of the OSDs. So it gives you similar. I guess 4+2 would be similar to RAID 6 because you can lose the loss of 2 drives.
But still, you have to compute the file or calculate the file when you read it. Or
Right.
So you said chunks. Do I see that as the file is on 2 OSDs and you've got 2 chunks? Or
yeah. So if I basically have in that case 6 total chunks, and when I read the file back, I have to go read any 4 of those chunks.
Any 4 of those chunks
will give me the original file because of the way it can use the parity bits to recompute the original data bits and then attach them or bring them back together.
And what do you recommend? Is that a recommended option or?
So there's some performance overhead to doing that calculation, and offhand, I think a common number to think about is maybe 10% overhead for erasure coding, which can be plus or minus depending on the workload, of course.
Yeah, of course.
Frequently, a lot of users will use the erasure coding for object storage because with object storage, it's like you have a lot of data. It's unstructured. It's not usually dependent on high performance, and so the 10% performance hit is not a problem at all for the gain in storage that you effectively get to be able to put that much more data in your cluster because you don't have so much storage overhead. Now it's just a little compute overhead instead. So it is possible to use with block and shared file system as well.
Yeah.
And there's actually in the next Ceph release with Ceph Tentacle that's coming out in the next few months, there are some erasure coding improvements where they've really focused on performance and say, okay, we're going to really make this work even for block and shared file system as well. And so then I'm looking forward soon to some numbers to say, well, how is that working? How good is it? And because if the performance cost isn't as much, then surely everybody would love to use erasure coding more than the 3x.
Yeah, of course, it saves storage.
Yes, lots of savings there.
Yeah, that's awesome. If I set up a Kubernetes cluster, is that then recommended to do Ceph on every node in your cluster, or do you split off and say those 3 nodes are Ceph nodes, or 5 nodes, or yeah. How do you do that? What's the best mix?
That's a good question. It kind of depends on how much performance you really want to get out of your cluster, or how constrained you are for your cluster. If your cluster size is only 3 nodes, then
yeah, of course
you're going to run on the same cluster. If you get 6 nodes, well, maybe you can choose to dedicate 3 nodes to run Ceph, and then the other nodes can be out, for your applications, just using taints and tolerations and things. It's easy to configure it that way with Rook. Some people also prefer a third mode where they're really, Ceph. They're really Ceph storage nerds, I'd say. They love to just do Ceph without Rook or any Kubernetes, so they'll be running Ceph in a separate bare metal cluster and they deploy Ceph with the Ceph ADM tool. And so that's the third mode where this is an external cluster, and now you can connect your Kubernetes cluster to that just by using the CSI driver that Rook will deploy for you. So that's the complete separation mode. In general, though, I'd say if people are friendly to Kubernetes and Kubernetes admins, if they're already familiar with Kubernetes, well, just deploy Ceph on the nodes. If you really want to tune the performance, I'd recommend, set aside several of the nodes for Ceph, depending on how much you want to scale it. Be more nodes, obviously, and then by separating your applications from the storage, you know that the applications won't affect the performance of Ceph itself while it's providing your storage platform. Even if you're running on the same nodes, if you don't worry about separating it all out, by setting the resource constraints with resource limits and requests and limits, Ceph, usually runs perfectly fine on the same nodes, since with the C groups, and that you can get those restrictions and guarantees of performance with for memory and CPU, and then it's fine to run the same nodes. So that's kind of a long answer to say you can do it any way you want.
Yeah, okay. Imagine I've got a really big cluster, and I've got on every node I've got Ceph running, and I've got my workload, my application that needs storage. Is there a possibility that Ceph moves his data to the node where the pod runs?
For locality.
Yeah, locality.
For that case. The Ceph, that's a common question we do get for Ceph.
Mm-hmm.
But Ceph being a purely software-defined storage, it does not have that locality. So if an application really needs local data for as high performance as possible, say a database really needs a local disk performance, I'd recommend just use a local PV, and the application itself hopefully then has its own redundancy built in. Say you've got a MySQL database. Well, MySQL has its own level of replication. Then you don't even need a storage system that replicates and provides that necessarily.
So then you recommend used host file.
Basically a host path.
Host path, yeah.
Or a raw disk dedicated, a raw PV dedicated to that for absolute highest performance where you need data locality.
Okay. And another question. Multi-tenancy. Imagine I've got a cluster with 4 different customers on there, and they all want their own storage, and the storage cannot be interchangeable. Is that possible, or is that?
Yeah, there's several different levels of multi-tenancy that will work with Ceph. Ceph can be divided into where you can say, so your pools, and this is back to the crush map. The crush map will allow you to define what OSDs are used by each Ceph pool. And the pool is you associate a pool with your block storage or your file storage or object. So you can say, I want this pool, and this pool will use this set of OSDs. And so at that level, you could divide, you have your multi-tenancy where you say this pool should use this set of OSDs, and that pool use that set of OSDs. That's kind of a heavy solution. Another solution is if you just use all of the same OSDs, you can define what's called Rados namespaces for using block storage, and the Rados namespaces will really give you kind of independent consumption of those OSDs without allowing the storage not visible between the different tenants, essentially. So each tenant could have its own Rados namespace.
Yeah.
And using the same pool, the same set of OSDs, and that's commonly the sufficient level of isolation. And even another level of isolation, if someone really wants independent, you can have separate Ceph clusters that Rook will configure within the same Kubernetes cluster.
And that's a lot of overhead.
So that there's even more overhead for that too. Yeah, it's very similar to separating the OSDs, but Rados namespaces are the best recommendation.
Okay, that's awesome. And if you have 2 separate Ceph clusters with Rook, do you need to do something special, or do you just install them in different namespaces?
Yeah, that's exactly it. Rook requires each Ceph cluster to be in its own namespace, its own Kubernetes namespace, and there's one Rook operator that will watch for there's the Rook CRs, there's the Ceph cluster CRD, so we'll see, it's in this namespace, I'll go configure Ceph in that namespace, and there's another one in that namespace, I'll go configure it in that namespace as well. So there's multiple namespaces.
You've got a lot of experience. What is the biggest mistake people make when they install Ceph or Ceph Rook?
The biggest mistake? Yeah, that's a good question. Let me think about that for a second. Yeah. I'd say commonly, I like to talk about that topology aspect because if you need to really understand what level of failures you can tolerate, and if people don't understand that, it's possible to reconfigure later, but then you have to move data around um, to accommodate the new topology. So I'd say understanding topology and configuring those failure domains
Yeah.
is an important one.
Think before you do.
Right, right. and but at the same time, I feel like once people can get up and work running pretty quickly if they just try it out, and if they run into issues, they have. I mean, they ask questions. They've got the Rook Slack. They've got other Ceph resources where they can ask, and I feel like people can troubleshoot a lot of things on their own. But once they get it running, we don't hear a lot of questions. It just works well for them. Is how I feel about it. Of course, people probably troubleshoot things all the time we have no idea about. But once it's initially working, if they've actually followed through the Rook documentation, the quick start guide and things to get started, that'll usually get them pretty far. There are lots of intricacies of Ceph to understand too that can, as you want to expand on that power and understand more what the capabilities, that there's still the complexity is still there if you want it. But
And if you then do the quick start, do you end up with a production ready cluster?
that's right. Yeah. So the quick start guide walks you through creating the cluster that enables block, file, and object storage, all for production level with Rapid to 3 by default.
Okay, awesome. Thank you. I'm ready for my last question. Our last question is always, how do you see the future of Kubernetes? And in also in with Rook and Ceph.
Yeah. Well, it's been a great journey so far in the last 9 years, like 5 years since Rook was a graduated CNCF project. It just keeps growing and growing. I don't see any end to that growth. And I think it's a testament to how, the open source community really has received the Ceph project, and then people trust the Ceph project. Oh, I trust Ceph with my data. It's shown to be reliable. Even if I have to pay a performance cost, like the reliability is so important for data. And so people need to store their data somewhere with Kubernetes. Kubernetes was designed all about stateless applications.
Yeah.
And it's like, wait, what about my data? Where do I put my data? And that's where that need is not going away. It just keeps getting bigger and bigger. AI consumes more data all the time. So I see, the community growing around it, even just more over time. And storage is just such a core part of that. So I don't have a feature list to say, well, we really need this feature and that feature. It's like, well, we continue to support new Kubernetes features. Ceph features keep getting added to the data platform. And Rook, we do our best to expose the Ceph features in the CRDs that we have. So, and it's all about supporting the storage ecosystem with a platform that works well. We want to make it work at Ceph. We want Ceph to work as best as it can for Kubernetes. So my vision is to see it keep growing and keep responding to the community requests and all of that.
Ceph takes over the world.
Right, the storage world.
Yeah. Okay. Thank you, Martin, very much for your time, and we'll keep Ceph and tightly eye on.
Great.
Thank you.
Thank you.